Okay, so we're going to continue on our discussion of expanding a logarithmic expression, but we're going to put a bunch of these properties together while we do it. In order to perform this task, I usually like to follow a set of rules or procedures to kind of make it a little bit easier. So over here on this side, I have kind of a flow chart, so to speak, of how I'm going to approach expanding the examples that we're looking at. So we're going to do each of these three things as we move down. Okay, so we're kind of going to go in order. So the first example that we're looking at says log base b of this expression right here. And if we're following these rules over here, we're going to apply the negative exponent rule. The negative exponent rule is going to allow me to move this z out of the denominator and up into the numerator. So this looks like log base b of x squared y z to the negative 2. Remember, that's the negative exponent rule. When I change the position of the base, it changes the sign of the exponent. Now let's talk about the product rule. The product rule has to do with our log rules that we've been discussing. The product rule says that I can take these three terms here that are in the argument and write them as separate expressions. So this is log base b of the first term x squared plus log base b of the second term y plus log base b of the third term z to the negative 2. So that's the product rule. And finally, we have the power rule. Remember, the power rule in logs lets me take this exponent here and bring it down to the front. So this looks like 2 log bx plus log by minus, because that negative 2 comes down, minus 2 log bz. And that is an expansion of this log expression. I have three terms you can see written down here, and that's the way we work it. Okay, let's try the next one over here. This one's going to be probably a little bit more challenging, but that's why we're doing it together. I want to talk about log of the fifth root of xy. So as has been the practice in the previous videos, we want to change out of a radical and rewrite this in its rational form. Rewrite the argument in its rational form. So that looks like the log of x over y raised to the 1/5 power, or 1/5 power, because that's a 5 there. So now what do? Well, I'm going to go ahead and I think at this point I'm going to follow the negative exponent rule. So I'm going to go ahead and bring y up by rewriting this as x y to the negative 1 all raised to the 1/5 power. Now, here I have, within this argument, I have a power to a power. So I have kind of a double idea here. So I'm going to use my rules of exponents that say if I have a power to a power that I just multiply the two powers together to simplify this argument that you see right here. So this is going to be log of x to the 1/5 y to the negative 1/5, because a negative 1 times 1/5 is that. And now I have just this kind of simplified version of our argument so that I can apply the product rule to. The product rule for exponents. So I have two terms in the argument. This is going to separate out into the log of the first term, x to the 1/5, plus the log of the second term, x to the log y to the negative 1/5. And now we apply the exponent rule, which allows me to bring that exponent down in front. 1/5 log x minus 1/5 log y. And that's the expansion of what we started with right here. The key to this one is just to change the argument out of its radical and put it in its rational form. And then I guess you still have to remember those rules of exponents that allow me to simplify this argument even further. Alright, so here's the challenge one down here. This is the last example we're going to look at together in this video, and it's the longest one. So how are we going to approach this? First off, I'm going to take the argument here and I'm going to rewrite this from radical into rational. So this looks like the ln of x to the fourth. Now here I have x squared plus 3 all under the radical, so I can rewrite it in its rational form as x squared plus 3 raised to the 1/2. Then I have the denominator x plus 3 to the 5th. So I also, I guess the next thing I want to do is I want to apply the negative exponent rule. So I'm going to take the denominator here, I'm going to bring it to the numerator. So I have everything in my argument in the numerator. X to the fourth, x squared plus 3 to the 1/2, x plus 3 to the negative 5th. So far that's what I have in my argument. Now I have powers, I have the product rule that I'm going to apply. And the product rule says that I'm going to take each of these three terms and write them as their separate expression. So natural log x to the fourth plus ln of x squared plus 3 to the 1/2 plus ln x plus 3 to the negative 5. And then the last thing that we're going to apply is the power rule. So each of these exponents are going to come down into the front. So I have 4 ln x plus 1/2 ln of x squared plus 3 minus 5 ln x plus 3. I'm kind of looking at each of these arguments just to make sure that I can't simplify them any further, and I can't. So I have three terms here in their expanded expression, and that's kind of the process or the procedure that we're going to use for each of these in order to expand the expression.